Right, weird sequences, Jamie hitting a target, finding the arc length of a slice of pizza. Watch this video and explain to you all how to get the answers to this January, February, March 2023 paper. Where are we now? 22 extended. Yeah, join me. Question 1. Right, cube numbers. Remember, cube numbers, a number you multiply by itself 3 times. So like 1 cubed will be 1 times 1 times 1 is 1. 2 cubed will be 2 times 2 is 4 times 2 is 8. So 3 cubed will be 3 times 3 is 9 times 3, 27. And that is what we're looking for, 27, cube number. Prime numbers, numbers only has 2 factors. 1 and the number itself. For example, 12 is not a prime number because it's got 1 and 12 as factors. But it also got 2 and 6 and it's got 3 and 4. Way too many factors there, yeah? So we go along there. 15, you got 1, 3, 5, 15, 27. Of course, 1, 3, 9, 27, 29. By the way, can you think of anything that divides in 29 other than 1 and 29? Nope. That's why that is the prime number. 91, is that a prime number? No, I don't think it is, because if you do 91 divided by 7, get all numbers. 7 and 13 are factors there. Okay, so those are the only correct answers. Let's see this mark scheme here. 27, 29. Right, column vectors. Remember what column vectors mean. We got a vector V. The number at the top, the -1, tells you left or right. It's negative, so you go left. 1 square. I don't have squares here, but that means -1. You move 1 space to the left. The 3 will mean you go 3 spaces up. And that will give you the vector. The vector is that one going that direction. That's the vector V. Okay. The vector Y, of course, will be 2 spaces to the right and then 5 spaces up, and it is a big ugly, sorry, so that will be the vector, goes like that, Y. Now when we subtract them, it's actually quite easy. You just take the vector V, which is -1, 3, and you subtract from it the vector Y, which is 2, 5. So you do -1 minus 2 will give you -3. And 3 minus 5 will give you -2. Which, by the way, let's do this in bright orange, would be then 3 squares to the right. And 1 squares down, 2 squares down, because that will be the result of the 2 vectors together. Okay, don't want to complicate it, you just subtract the top from the top, the bottom from the bottom. Okay. Next one, 2V. The vector V being 2, 5 again. Yeah, you know, like you got the vector 2, 5, which means you got 2 spaces to the right, 5 spaces up. That will give you the vector Y, V, V. You see, I took the wrong one. I took Y again. Stupid. See what the silly mistakes we can make? We're doing V. V is -1, 3. So yeah, you're going 1 square to the right, 3 squares up, and when you double that, you just do it again. So now the new vector will be twice as long, and that will be 2V. Again, it's a very long explanation. Okay, all you really need to do in the exam is do 2 times -1 is -2, 2 times 3 is 6. Just double the top and the bottom. So there we go, the correct answers, as you can see. Good old Venn diagrams. Okay, remember Venn, we got 2 things. We got the union. Union is nice because that includes everything. Right? If you've got A union B, everything in A, everything in B. You will shade both ovals there, everything. But when you have intersection, that intersection is a bit more picky. It has to be in A and it has to be in B. It has to be in both. So you want to shade that You're only going to shade where they overlap. That's what intersection means. Intersection. Okay. That's that. Okay. Whew, that's the only Venn diagram question. I wish there was more. I like these questions. Anyway, write down the next number in this sequence. Next number in this sequence. So let's see what's the difference. We're subtracting 6, subtracting 6, subtracting 6. So we keep subtracting 6, so that would be -1. Now for the nth term, what it is not n minus 6. Please, people, stop writing that. It's not that. Okay, we need to think more in terms of what other sequence has this pattern of -6. Okay, and that will be the -6 times table. The -6 times table will go -6, -12, -18, -24. Yeah, because 1 times -6 is -6, 2 times -6 is -12, 3 times so our rule will start with -6n. Okay, difference here being we don't start at -6, we started at 23. Then there's 17, then there's 11. So how do you get from 23 to -6? Well, you need, from -6 to 23 rather, you need to add, of course, 29. Or the other trick is, we want to go to the back, you continue the sequence, the original sequence, the opposite way. If you have to put the 0th term, the term that goes before the first term, that of course will be 29, because 29 minus 6 is 23, so that's what you get to. Okay, and that's the correct answer. The mark scheme, usually they just write it the other way around, but it doesn't matter. Okay, because it says or equivalent OE. So -6n plus 29 is perfectly good answer. Question 5, factorize. Let's rip this apart first. 8 we can write as 2 times 4 times g, those dots meaning times, of course, -2, and g squared is g times g. So let's look at what's the common factors there. Well, they both have a 2, both have a g in there. Okay, so that is, okay, completely means we need to take out all the common factors. So you have to take out the 2 and the g. In the brackets goes what's left, 4 and minus g. And that's how you get full marks. Okay. If you only partially factorize it, you only factorize out the 2 or the g, you only get 1 mark, of course. Completely means you need to factorize out both the 2 and the g. Next one, you without a calculator do this. Okay. Now, what is 8? Well, 8 as a fraction is 8 over 1. Because 8 divided by 1 is 8, so still the same number. When we divide with fractions, it's invert, multiply. You invert the second fraction only, the first one stays the same. So you come 1 over 8, and we multiply. Multiplying fractions is easy as pie, of course. You just multiply the numerator with the numerator, and the denominator with the denominator. 4 times 1 is 4, 7 times 8 is 56. Okay, are we correct? Well, nobody said you can't check it with your calculator. It just means you need to show every step. Okay, 1 over 14, is that what we got? We got 1 over 14, well, 4 divided by 56. Yeah, it simplifies to that. You see that? So we just know we need to divide the top and the bottom by 4, and that gives us 1 over 14. Okay. So basically what it tells you here is you get 1 mark for that working out, and then if you got that mark, they give you a mark for the answer. If you just write the answer, 0, because they'll assume you use the calculator, of course. Question 7, solving. Alright. Keep the equal signs in line. It makes life so much easier, right? So I'm going to keep the 15t on the left. We can say we are adding t to everything, or we're moving this negative t. That becomes a positive t. We leave the 4 where it is, and move the positive 8 becomes negative 8. Change sides, or you subtract 8 from both sides and you add t to both sides, whatever way it works for you. 15t plus 1t is 16t. 4 minus 8 is negative 4. Don't get that confused. So the last thing is we divide 16 from both sides. And there we get the answer, minus 4 over 16. I bet you can write that, but if you want to simplify, of course, there's nothing wrong with it. You divide the top and the bottom by 4, it gives you minus a quarter. Okay, minus 0.25. You know, anything like that. See, it says or equivalent. So I'm sure if you write a decimal, minus 0.25, correct. Yeah. And yep, they give you a mark for doing what I just rearranging, basically, like that. Question B, solve it. Okay, think about it this way, right? You see the whole 25 minus 2u is being held captive by that 3, because everything is being divided by 3. So your first step is you have to move that 3 first, okay? Get rid of it. Multiply everything by 3. Divide by 3 becomes times by 3. Whichever way you want to see it. Okay, either way, it's 2 times 3. So 25 minus 2u equals 6. Okay, you can move the 25 to the other side or subtract 25 from both sides, but then we're going to end up with negative. So I rather do, I like it small. I'm going to add 2u. Or move the minus 2u becomes positive 2u. Just nice and more positive. Yeah. The 6 then we can move to the other side, and this is just the 6 means a positive 6. So that becomes minus. So 25 minus 6 being 19. So 2u is 19. So 19 divided by 2 will give us u, which is 9.5, of course. Okay. So 9.5 or equivalent. So 19 over 2, probably get your answers there. Okay. Question 8. Calculate 0.3 squared. I mean, nobody says you can't use a calculator. So we do it. And we get 0.09. 0.3 times 0.3, 2 decimal. Yeah, you got it. But now we need to write it in standard form. Remember, standard form has got a number, which is 1 to 9. So 1 point something, 5 point something, 4 just 7, you know. Times 10 to the power of something. That's standard form, or scientific notation. Okay. So we need to get a whole number in front there. So for that we can move the decimal point 2 spaces. That gives us 9 times 10. And because it's a small number and we move the 2 spaces, it's going to be minus 2. Okay, there's other ways to do this with your calculator. Alright, you can press shift, set up, press 7 for psi, and then we have to pick a number between 0 and 9. Because we're usually around to 3 significant figures, 3 is a good option. Okay, and equal, and there it gives you answer in standard form. It put 0.00 because we pressed 3, so it gives us 3 figures. See, there's the answer. Easy as that. And all your answers, if you put in any number, it will give it to you in standard form to 3 significant figures. Change it back, press shift, set up. We want normal back, so we press 8. Press 1 or 2, doesn't matter. I like 2. And then it gives you the... Well, that's not going to work because the screen fills up. But anyway, it's back to normal. Okay, you don't believe me? So the calculator's gone. Oh my goodness. Okay, it's back to normal. It's back to normal. See? Right. Question 9. Simultaneous equations. Now they've been nice. They lined up everything. You see, we got the equal signs lined up. We got the y's lined up. We got the x lined up. This is perfect setup for the elimination method. Okay, elimination method means we get rid of the x, we get rid of the y. We do that by adding or subtracting the 2 equations. Now we're going to add these 2 equations. 3x plus x is 4x. Minus 2y plus y will give us minus 1y, right? It didn't work. We still have an x and a y. We haven't eliminated anything. We want to eliminate one of them so we can work out the other one. If we subtract them, will this work? Let's see. 3x minus x will give me 2x. 2y minus plus y is 2y minus y is minus 3y. We haven't eliminated anything. See, it's not going to work because we need to get the coefficient of the x and the y the same. That number in front of the x, it needs to be a 3 as well. Or that number in front of the y, it needs to be a 2, the one or the other. So what I'm going to go for, because I like smaller numbers, I'm going to put a 2 in front of that y, but the only way to do that is to multiply the whole equation by 2. Okay, or else the equation is not true anymore. Okay, you can't just shove a number in there. But if we multiply everything by 2, the equation stays true. Okay, so I'm going to write the answer here. Everything times 2 will give us 2x plus 2y equals 6. Okay, I'm just going to take that first equation and write that down again. So that's 3x minus 2y equals 19. Right, now, let's change color. We can add or subtract these two equations together. Right, so if we're going to subtract them, we get 3x minus 2x is x. Then we have a minus 2y. Remember, we're subtracting everything. Minus a positive 2y. A plus and a minus is a minus. That gives us minus 4y. Again, we have not eliminated everything. Anything. Not everything. Anything. Okay, so subtracting is not going to work. Let's try adding. 3x plus 2x will give us 5x. And minus 2y plus 2 pluses is a plus. Of course, it's just like adding. So minus 2y plus 2y gives us 0. And that is what we were looking for all along. That means we've eliminated the y's. Great stuff, because our 19 plus 6 is 25. And now it's easy to find the x. So the x will be 25 divided by 5. So x is 5. Heaven on earth. Okay. Of course we need to find the y, but that's not sweat at all. Okay, just take any of these equations. Any one. That one looks the easiest, doesn't it? So we take x plus y equals 3. We know x is 5. We just worked it out. So to find y, we need to subtract 5. So y is minus 2. Is this right? You can always check it, yeah? Check the other equation. Let's take this one, which is 3x minus 2y equals 19. We just said x is 5 and y is minus 2. 3 times 5 is 15. Minus 2 times minus 2. 2 negatives makes a positive. 2 times 2 is 4. 15 plus 4 is 19. And if you get something that is correct, then your answer is correct. If we got something that wasn't correct, then it wouldn't be right. So we know it's right. And mark scheme says that as well. 5 and minus 2. Okay. Question 10. Things are heating up a little bit. Right, doing question 10, one is tempted to try trigonometry. You see the triangles and they ask for a side. You can work out some angles. You can use the sine rule, the cosine rule to work out some angles and work from there. Okay, and you can get the right answer according to the examiner's report. Okay. But they say some people very often make mistakes doing that because they were rounding too early. They say the most successful candidates, okay, notice that you need to use similarity. It means these two triangles are similar. Why are they similar? Well, because of the parallel lines. Okay. We got the two opposite angles are equal, And then we got the alternate or z angles. This angle equals to that one, and this angle equals to that one. So you see they are the same triangle, just different sizes. So they're similar. So they've got a scale factor, a ratio, that the bottom is bigger than the one at the top. Okay. How do we find that ratio? Well, we just need to divide the one by the other. Okay. So if we take a side that we know corresponds, okay, and that's the side AB over CD, or the other way around, right? We'll do CD, the longer one, over AB. We have 7.5 divided by 3, which will give us 2.5. So that tells us the bottom triangle is 2.5 times bigger than the top one. Okay, or if you write it the other way around, we get 3 over 7.5. What's that going to give us? Okay, 0.4. So that means this small triangle is 0.4 of the big one. Okay. So how is this going to help us? Well, they want the length of BC, which is the whole line over there. All right. Which is difficult to find. But let's just start by doing CX, this one here. Okay. So CX, can we work out how long it is? Now be careful here, right? So remember when we did the alternate angles? Okay, let's do it again. We said this angle is equal to that one, and this angle is equal to that one. So there's a twist. Okay, AB corresponds to CD, but CX, this angle here, this side, okay, which includes the orange angle, corresponds with that one there. Okay, so what it comes down to is that CX is 2.5 times bigger than BX. All right, or if you want to write things really the correct mathematical way, we know the bigger one, CD over AB. Okay, CD over AB will equal CX over BX. Now because you know CD is 7.5 and AB is 3, we don't know what CX is, but we know that BX is 2.7. Okay, 7.3 to 3 is equals 2.5. Multiply the 2.7 over there. That gives us CX. Okay, so CX is 2.5 times bigger. A little confusing. But then we got it, 6.75. Right, so we know this is 6.75. But we don't want to know CX, we want to know BC. So BC, of course, will be 6.75 plus 2.7. Okay, just adding these two values together. All right, don't complicate things. We just add it up, and you get 9.45. Smart, isn't it? 9.45. Okay, like I said, you can go trigonometry, but yeah, you're gonna get weird answers. You're gonna have to rounding. You're gonna have to move stuff around, and you can get the right answer. But this is what they wanted, really. Question 11. Find the highest common factor of 12x to the power of 12 and 16x to the power of 16. The highest number that can divide into both numbers. Okay. I mean, 12 and 16 is not that hard. What's the factors of 12? 1, 2, 3, 4, 6, 12. What's the factors of 16? 1, 2, 4, 8, 16. Highest common factor there, 4. See, that's 1 mark. Next question. What's the highest common factor of x to the power of 12 and x to the power of 16? What can we divide into those numbers? Right? What can you divide into x to the power of 12? Well, you can divide x2 into it, because then you get x to the power of 11. You can divide x squared into it. You can get x to the power of 10. You can divide x cubed. In fact, you can divide x to the power of 12 into x to the power of 12. You get 1. Okay. What about x to the power of 16? Well, that's the question. Can you divide x to the power of 16? You can, but then you're going to get, what are you going to get? You're going to get a negative. You're going to get a fraction. You're going to get 1 over x to the power of minus 4. Now that's not nice, alright? So the biggest thing you can divide into x to the power of 12 is x to the power of 12. And the biggest thing you can divide into x to the power of 16 that you can also divide into x to the power of 12 is x to the power of 12. Make sense? Well, that's the answer. Anyway. Okay. Question 12. A regular polygon. Okay, what is the ratio of the interior and exterior angle? Okay, let's write this down. So we got interior angle, I'm going to represent it by an I. We got the exterior angle. They tell us the ratio is 1 to 11. Now remember, if we've got a polygon, let's draw a polygon. Which one? Pentagon, oh, pentagon, yeah, pentagon. Okay, pentagon. What's the size of the interior angle of a pentagon? Well, the exterior angle is easy to find. It's 360 divided by 5, of course. Yeah? You just do 360 divided by 5, 72. So the exterior angle of a regular pentagon is 72. So the interior angle is 180 minus 180. Yeah, see? So they always add up to 180. Interior exterior angle, right? So it means when we add the interior and the exterior angle, we should get 180, but when we add this ratio, we get 12. Well, we should get 180. So it means that the interior angle is 1 degree, the exterior, oh, see, I got it the wrong way around. Okay. The interior angle is 11, the exterior angle is 1, it adds up to 12, it can't be correct, it needs to add up to 180. So we need to keep doubling it, or changing the ratio until the sum is 180. So how many times are we going to do that? Simply see, how do I get from 12 to 180? Okay, how do we get from 12 to 180? Well, I do 180 divided by 12. I need to times it by 15. So I'm going to multiply my ratio by 15. That means the exterior angle is 15. So the interior angle must be 165. Or 11 times 15 should be 165. Of course. Bam. Okay. So I now have the actual interior angle and the actual exterior angle. Okay, so it's a polygon. I don't know how many sides got. 165, 15. Okay, how do we find the number of sides? Well, you see that our pentagon here, if we simply do 5 times 72, we get 360. So if the exterior angle is 15, I do 360 divided by 15. What is that going to be? .24 sides. Easy as that. 24 it is. Oh my goodness, they made it complicated there. I think my method makes more sense, yeah? Use the ratio. Remember, equivalent ratios is always easy to use. Question 13. Speed time graph. Alright, what do we need to remember about speed time graph? Is that the area under the graph is the distance. Look at this, right? This is times in seconds. This is speed in meters per second. If I multiply meters per second by seconds, that cancels out. Left a meter. Meter is distance. So now the units kind of tells you what to do. Okay. We want meters. We just multiply together. So, in the first 8 seconds, we're traveling 10 meters per second, right? So for that rectangle, we do 8 times 10. That's 80 meters. So they traveled 80 meters in the first 8 seconds. Triangle got a base of 2 and a height of 10. Remember, the area of a triangle is half base times height. So that will give us 10 meters. So there they travel 10 meters while they were decelerating. Okay, 80 plus 10, 90 meters. Okay, got it right this time. Good. Question 14. Right, so according to the examiner's report, this is one of the more challenging questions on the paper. Okay, but we are smart. We gotta do this, right? So they want to know the length of the arc PQ. So immediately to mind jumps to the formula for arc length. Okay, so the moment you read that, you write, okay, so arc length is, of course, because the arc is part of a circumference of a circle, is the formula for the circumference of a circle times the angle, and the angle is that one over there, over 360. So immediately we recognize we're gonna have to find that angle there, or we can't use this formula. So what else do we have? We got a 9 and we got a 6. Do we know what is this? Okay. Yes, we do. Because this is the center of a circle and that's the radius going to the circumference, then this line will also be the radius going to the circumference, and the radius of a circle never changes. So that means that is 9 centimeters as well. Okay, you get what I'm saying? You got a circle, you got a wedge. If this is 9, that's going to be 9. They're both a radius. Okay, so we're making progress. How do we find an angle in a triangle? We only have the sides. Okay, it's not a right angle triangle. Can't use Pythagoras, can't use SOHCAHTOA. So there's only 2 options left: sine rule, cosine rule. Okay. The sine rule, we're going to have it, you need an angle and a side, always opposite angle and a side. So if we got an angle here, for example, we can work that out, we can do it, right? Cosine rule is what we're going for. Okay, so remember that cosine rule. Let's write it down nice. Okay, what is it? It starts off with Pythagoras, a squared equals b squared plus c squared and minus 2bc cos a. Memorize this. Pythagoras minus 2b cos a. Okay, what we want to work out is the angle A. In this case, it is indicated by an A, right? Now we can use this formula to work out the angle, or we can rearrange the formula. It's not difficult to do, or we can memorize the rearranged formula. Okay, so if you want to work out the angle, it's better to use this formula, right? So cos A, we got the A there. Then it starts off the same, b squared plus c squared, you see? Because we move the a squared there, it becomes minus a squared. And then we will move the minus 2bc cos a to the other side. It will become positive, and then we'll divide the 2bc. All right. Or just memorize that formula. And that's the one I'm going to use, okay, to work out the angle we want. So I'm going to start off by writing cos, okay, A, because now A indicates that we've made this A. Okay, so my angle now, that's A. Or we can put a big O, but you're going to think it's A. That's A. Okay, so then we got B squared and C squared. Now that is the two sides that includes the angle. In this case, they're the same. So that's 9 squared plus 9 squared minus A. A, you see, capital A, little a, there means always the opposite, yeah? Capital A is always little a, so that must be 6 squared. Okay, over 2, and B and C again was the two 9s. Okay. Now, before I like to put this into my calculator, I want to show you what are we going to do, because that will give us cos A. We don't want cos A, we just want A. So it means we need to move the cos to the other side. And that will be the inverse of cos. Okay, and this is what I'm going to put into my calculator. So let's do that. Okay, here we go. Shift cos bam, 38.942. Etc. Very important, looking at the examiner's report, they mention here quite a few rounded their angles to 2 or 3 significant figures in the work leading to the commonly accurate answer C. Okay, at least 4 significant figures. So this is not our final answer. So don't round this answer. At least 4 significant figures of 38.94. I'm just throwing that 2 there just to be more accurate. Okay. So we got the angle now. Now we can go back here and we can put the angle there. That's what we wanted. Okay. So let's go back to a nice beautiful color. So to find the arc length, we're now going to do 2 pi times the radius, which is 9, times that angle, 38.942 unrounded over, what's it, 360. So let's do that. Okay, so we're going to start with 2 pi 9 times. So what I'm going to do now, I'm going to insert the last answer there. So that's even more accurate. Got the whole answer there, 360. That's what we got, 6.117. Zero, etc. Now we can round stuff to 3 significant figures. 1, 2, 3, that's a 7, so that last one becomes a 2, 6.12 centimeters. Let's check. Yes, it's correct, and even a little bit less. So basically, if we were at 6.117, we got an answer as well, correct. Okay, so pretty good. All right, just be careful here, like they say. Inaccurate answer of 6.11. You see, if you rounded your answer too early, the final round is going to be wrong. You're going to lose a mark because it's not correct. Keep your head together. Smart. All right. Question 15. Right, you see all that number 3125 w to the power of 3125 is inside a bracket. That means everything is to a power of a fifth. So we got 3 1, 2, 5 will be to the power of 1/5, And this, remember, a power to a power means we need to multiply them together. So first, the first part there, okay, we can do 3, 1, 2, 5 to the power of 1/5. It's 5, okay. Also, of course, a fractional power means a root, so we could have done, no, there we go, root 5. See? Root 5 is the same as a fifth. Anyway, then we got the W, and then to find out what goes above, we multiply 3, 1, 2, 5 times a fifth, which is 0.2. So that would be 6, 2, 5. Yeah, final answer. We got it. Smart. Question 16. Let's get going. Proportion. We're talking about proportion. We use this little special sign, the fish. Okay, so y is inversely proportional. That means we need to write it as a fraction, 2x squared. If we want to change our little fish for an equal sign, we need to bring in the constant k. Now we got an equation that puts that first sentence, y is inversely proportional to x squared, in mathematical language. We can now substitute the x and the y's. The y is 2 and the x is 3 squared. 3 squared, of course, being 9. Multiply the 9 over there, so 2 times 9, k is 18. I can now rewrite our equation with the constant, which is 18 over x squared. So let's find y when x is 2. So when x is 2, that will give us 2 squared. So y is 18 over 4, or 9 over 2, or 4.5. Easy as that. 4.5 or equivalent to 4.5, 18 over 4, anything like that. Okay. Nice. Question 17. How beautiful these circle theorems are. So with circle theorems, it's very important to read every little piece of information they give you. They tell us A, B, C, this is cyclic quadrilateral. So immediately we need to think, what do we know about cyclic quadrilaterals? There we go. We know that in a cyclic quadrilateral, with all the corners on the circumference of a circle, opposite angles are 180. You see that 101 and 79, 180. 87 plus 93, 180. If we change it, yeah, opposite angles in a cyclic quadrilateral always add up to 180. Going back here, we know what to look for. We know that this angle here and that angle there, that will add up to 180. If we get it, and this angle here and this whole angle here, the 42 and that will add up to 180. Okay, so keep our eyes open for that when we need it. Second piece of information, ABX is a straight line. ABX is a straight line. Immediately we know that, let's just get some green in here. Okay, angles on a straight line is of course 180. So that means that this angle here will be 95. Okay, that's angle ABC, 95. All right. Oh, we got that whole angle there. That means that this angle here, okay, opposite angles, cyclic quadrilateral, add up to 180. So this will be 85. Oh, you see, we're making progress already. Okay. Next piece of information, we've dealt with this one. PQ is a tangent to the circle. So this PQ down here is a tangent. What do we know about tangents? Let's have a look. We know that tangents forms a right angle there, 90 degree with the radius. Okay, but our question, we don't have any radii, so that one's not going to be valid. Okay, we also know the alternate segment theorem. This one is important. This is one people often miss. Okay, so meaning, yeah, that we got a tangent and a triangle. Ultimate segment theorem means the angle over here, you see the green one, which is 61, is difficult to see. 61 is equal to that one over there, the green one, 61. And on the right here, 70 degrees, 70 degrees. Alternate segment theorem. Okay, so if we look at that, okay, let's use a different color a little bit. We got the 55 here, which forms the alternate segment theorem with this triangle. We need to look for triangles, yeah? So because it forms the angle between the tangent and the triangle, we know that this angle up here will be 55. Okay, let's just make things look a bit more pretty. Okay, so we know that one is 55. Okay, we don't have any other angles at the moment. Be careful that 85 is not a tangent. Okay, this angle DAP will be equal to that one. That's another alternate segment theorem. Oh wait, I think I've spotted another one. So we take this whole angle here, right, to the triangle ACD. It should be equal to 85. So that's 85. Again, alternate segment theorem. Okay, so that gives us a little angle there. 85 minus 55, that must be 30. Okay, look how much progress we're making. Okay, well, in fact, I can find angle PAD now. So if we do 180 minus that 85 minus 42, what's that going to be? 95 minus 42, 53. Is that right? 53 is angle PAD. Where's my calculator gone? 180 minus 85 minus 42, 53. Okay, sweet. So this is 53. Angles on a straight line. Oh, and then we got another alternate segment. This time PAD, the triangle DAC. So it means up there we got 53. Okay, then it just tells us the size of the angles. We've already used them. Does that 53 make sense? Because we do 85 plus 42 plus 53 gives us 180. Good stuff. And the other one, other triangle there, 30 plus 95 plus 55. To be honest, yeah, it's 180. Of course, 53 plus 55, that's 108. So this one here should be 72. It all makes perfect sense. You see what I get just by going through every piece of information quite slowly. We get a lot of information. Of course, another very popular tangent that we always use is the butterfly or the bow tie. Okay, angles on this in the same segment. Is it? Angles on the circumference is the same. So that's 52. That's 52, right? So if we look at ours, let's just color again. Okay, for example, this is 55. AB is the same chord that stretches there, so that's 55. Yeah. Okay, this is 42. That is 42. This is 53. That is 53, which add up to 95. Excellent. This is 30. That's 30, which adds up to 85. Everything makes sense. Yeah. So now we can go to the answers and we can just fill them out. First, CBD. CBD, we already had that one. That's 42. They're not asking for any reasons. ACB. ACB, we got that one already. 55. ADC. ADC, we got that one already. That was 85. BCD. BCD. There's those two together. 53 plus 55 being 90. No, 108, of course. 108. What you're up to here? 100. Get 2 marks for this one. And PAD, PAD, we had that one 53. See, without even looking at the questions, just by seeing what you can find, creates miracles. 42, 55. 85, 108, 53. Yeah, we got them all correct. Nice. Why is that 100? Yeah. Oh, you got one of those angles, ACD or BAC, you get 1 mark. Okay, so that's angle BCD. Okay. Not as hard as it looks, is it? Question 18. 2 solids are mathematically similar and have volumes of that and that. Okay. Surface area of a smaller solid is 45. So this is all about similarity again, yeah? You got actually the word there, similarity. Okay. So we got the big shape. I don't know what they are. Let's say they are just like a cuboid. Just envisage this. Let's say this one's 81 centimeters cubed, and the other one is 24 centimeters cubed. Okay. Now we can write this as a ratio. See how much is the one bigger than the other one. Okay. So since we want the surface area of the larger unit, we're going to put the larger one at the top. That's always good to put the larger value at the top, because this will give us the scale factor. This will give us the volume scale factor. Now, scale factor stays the same within the same units. So the surface area of the larger unit, we don't know what that is. Let's call that x. Okay, so that would be x. Surface area is centimeters square over 44 centimeters square. Okay, now this is not equal because the volume scale factor and the area scale factor is not the same. Okay, for example, let's do a different one. Okay, if you got a cuboid that is 1 centimeter by 1 centimeter by 1 centimeter, and you got a cuboid that is 2 centimeters by 2 centimeters by 2 centimeters, the linear scale factor, okay, to get from there to there is of course 2. It's twice as big. But the area scale factor, okay, if you take for example the area of the front face would be 1 times 1, it's 1, okay, would be the scale of linear scale factor squared, because 2 times 2 is 4 centimeters squared. So you don't times it by 2, you times it by 4. If you're going to take the volume, which is 1 times 1 times 1, you need to take the linear scale factor and cube it, because 2 times 2 times 2 times 2 will give you 8 centimeters cubed. Okay, it means the linear scale factor gets squared when we go to surface area or area, and it gets cubed when we work with the volume. It's the same thing here. We got cubed on the right, square on the left. We need to get this the same. Okay, and the best thing to do is here is do the following. Stay with me. Okay, because we have volume scale factor on the left, we need to cube the scale factor on the right. And because we got area scale factor on the right, we need to square the volume scale on the left. Does that make sense? Okay. Now, of course, I wrote the units, but we don't use the units in the calculation. It simply tells us what we're working with here. Okay. So we can write this more simply as 81 over 24 squared equals x over 44 cubed. We now need to solve x. Okay, the first thing I want to do, I want to set free the x over 44, which is being held captive by the cube there. So it means we cube root the other side. And then as well, after we've done that, we can multiply the 44. So we times that by 44. Just notice the 44 is not under the cube root. So I want to know what it is. I put it into my calculator. We start with cube root. We're going to need a bracket here. 81 over 24 squared. Use the arrows to get out from underneath the square times 44. So x is 99 centimeters squared. Okay. I mean, another way to understand this maybe is we take the scale factor of the volume, which would be as just a normal number, 81 over 24, okay, 3.375. Then to find the linear scale factor is we need to cube root that. See, we're now going from here to there. Cube root my previous answer. That means the linear scale factor is 1.5. That means if we square that, we get the surface area scale factor, which is 2.25. So finally, we just take the surface area of that one, 44, and we times it by the scale factor, and we get the same thing. Okay, it's two ways to break the same egg. Okay, there we go. Mine is a bit more similar to what the mark scheme says, although they use fractional indices, where I just use the roots. Either way, that's question 18. Okay. It was quite a challenging question, so if you're having a headache, don't worry, you will figure out. Okay. Question 19. Find the value of x when 6x plus y equals 10 and y equals x squared minus 3x plus 10. First thing I would want to do here is get rid of that y, because I cannot work out what is x if there's a y in the way. Okay, and for this we'll use the substitution method. I'm going to use this equation, we'll call it equation 1. I'm going to rearrange it, right? So if we got 6x plus y equals 10, just move the 6x to the other side. Now we got y equals 6x. No, we don't have that. We've got the 10. The 10 is still there. Minus the 6x. Alright. What we can do now, we can put equation 1 into equation 2. Alright, you see all of this? Right, all of that, 10 minus 6x is equal to y. So, in our equation here, where the y is, I can just put all of this. So instead of y, I write 10 minus 6x equals x squared minus 3x plus 10. Right, we got a quadratic equation here because it's an x squared, and as you know, quadratic equations always forms a parabola. It crosses the x-axis in two places, and that's why we will have two answers. To be able to do that, I need to set it equal to 0, because that is what the y is, and that point there on the x-axis, y equals 0. Okay, so let's just shove everything to the right. So there's going to be nothing left here. I've got an x squared minus 3x plus 10. The 10 there becomes minus 10, and the minus 6x becomes plus 6x. We now have x squared minus 3x plus 6x will give us plus 3x. 10 minus 10 being 0. Okay. So usually we'll make two brackets, we'll factorize those two brackets, but now we don't have a third term at all. Okay, so we can just factorize. We factorize out that x, an x from there, and x from there, it gives us x in the front. We're left with one x here and a plus 3 there. Okay, now we can split it up. Okay, we know this part, this x here tells us x equals 0, and that one there is x plus 3 equals 0, so x is minus 3. So instead of looking something like this, our parabola looks something like this. Okay, going for 0 and minus 3 on the x-axis. And that is a sensible answer, which is correct. Okay, so remember the show working out. Basically, they give you 1 mark for that, 1 mark for that, and then 1 mark for the answers, it seems to me. Question 20, and again here, it was one of the more challenging on the paper, particularly B. I found A bit harder, but anyway, let's have a look at his. First of all, when you see a sequence, you're going to look at the difference. So first we add 1. Then we add 7. Then we add, what is that, 19. And then we add 37, right? Oh my goodness. So we add something different every time. Okay. So adding something different every time reminds me of sequences, arithmetic sequences. Yeah, that was one with the power. So if you look at it, for example, n squared, yeah, which is the square numbers 1, 4, 9, 16, 25. You see, you will add 3, then you add 5, then you add 7, and then you add 9. So you add 2 more each time. Okay, let's see. So what do we get to? Then we add 6, and then we add 12. And then we add 18. So again, that second difference is not the same like in square. So let's try the next one down the line. N cubed, which is the cube numbers. 1 times 1 times 1, of course. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. So this time we add 7. Then we add 19. Something looks familiar. Okay, so that will be 12, and then 18, and then 6. You see, we got like a third difference there, which we definitely have here. Okay, so that means the third difference is 6. We got a cubic sequence at our hands here. All right, so let's write this down. Cubic sequence goes 1, 8, 27, 64. Remember now, this is the, let's just use a different color here. This is the first term, second term, third term, fourth term. We put in a fifth term there. 5 times 5 times 5 times 5 times 5, 125. That will be the fifth term, of course. Now let's look at the sequence we have. -1, 0, 7, 26, and 63. So some slight differences here. Okay, it's kind of like the whole sequence is shifted to the right, to the left, to the right, to the left, to the right, to the left. Yeah, you can see there's something in common here. That they're almost the same. Each time it's just one less. So it's like having n cubed, but having it with one less. Yeah? 7 minus 1 is 8. 26 minus 1 is 20. 0 minus... Right. I mean the other way around. 1 minus 0 is 0. 8 minus... So yeah? So it's that sequence with one left. Then it also shifted to the left. So remember, this is n. Okay? So for the sequence we have, we end up 1 to the left. So I mean the n number for this one here just needs to be 1 less. That will make the whole sequence shift. Okay, so that means the n, we need to subtract 1 from that. Okay, but that is before we cube it. Does it make sense? That's one way of doing it. Amen. So we want the first number in the sequence is going to be 1 minus 1 cubed minus 1, which gives us minus 1. You see? We want the second number in the sequence, which is 2 minus 1, which is 1. 1 times 1 is 1, minus 1 is 0, etc. And that's what gives us n minus 1 cubed minus 1. Okay, now don't fret, okay? Looking at the mark scheme, you get a mark for just recognizing that second difference, or recognizing that it's a cubic graph. That's it. And then to get full marks, you need to have that. So you can easily get at least 1 out of 2 marks. I mean, this is really a question I put in there again to try and make sure nobody gets 100% because they're bullies. Okay. Right, question B, they said it's a bit harder, but if you can recognize one thing and one thing only, this is a geometric sequence that we are not adding or subtracting something, but we're multiplying, right? Or rather dividing, or yeah, I said multiplying by a half. Maybe that's the best, because we multiply that by a half, then we half the number we had before. Or we divide it by 2. Geometric. And geometric has got this formula. Okay? Which is not that difficult actually. It's A being the first term in the sequence. That's a 1, that's a 1. Okay. Times, with a dot, R, which is the rate, to the power of n minus 1. That's it. So it means here the first term being 24 times that by the rate, which is a half, because we're multiplying by half each time, to the power of n minus 1. Okay. Can't multiply the 24 and a half because the half's got a power and an unknown at the top. So it's not 12, right? That's the answer. You see? There you go. Or equivalent. So there's other ways to write this and work this out then. Okay. So I think what's equivalent to this, it would be anything 24 2 to the power of minus 1, n minus 1. So that would be 24 2, just swap that around then, isn't it? 1 minus n, which is 24 times 2 times 2 minus n, because we're adding it together. Yeah, something like that. Doesn't matter. Don't complicate things, right? Okay, just remember that. Geometric, it is when you multiply, when you double something, you triple something, alright? Or you divide it by 3, so you times it by a third, rub it in there. You see, they said this was the harder part. There is equivalent answers in, yeah, this is kind of what I wrote down. Okay. This was a tough question, right? No doubt about it. One of the more challenging on the paper, as they said. Question 21. Was this one challenging? Okay, let's get through this. Right, car travels at 14 kilometers correct to the nearest kilometer. That means bounds to the nearest kilometer, to the nearest 1 kilometer. Okay, so you take that 1 kilometer, you divide it by 2, you get half a kilometer. That means the lower bound for that vehicle traveling could have been 14 minus a half kilometer. Could have been traveling at 13.5 kilometers. Okay, or the upper bound, you add that. So it could have been traveling at 14.49 recurring, or around at 14.5, not inclusive of 14.5. No? So that's the lower bound, upper bound of the speed. It takes you 12 minutes to drive this to the nearest 1 minute. You take 1 minute, you divide it by 2, you get half a minute. So again, for the lower bound of the time, it could be 11 and a half minutes if it went fast, or the upper bound 12 and a half minutes. Okay, so the time was somewhere between that. Now we need to calculate speed. Remember, speed, distance, time. Let's do that. Speed, distance, time. Okay. So we need to calculate the lower bound of the speed, the slowest possible speed it could have traveled at. Okay. Now, if you've got your head and your ducks in a row, you know what's going on. You know that to get the slowest possible answer, you need to take the smallest possible distance and divide it by the biggest possible number time. Okay? If that's confusing, let's just do it all. Yeah? 13.5 divided by 11.5. Okay? This is the lower bound divided by the lower bound. Okay, what's that going to give us? 13.5 divided by 11.5. 1.174. Let's do 4 significant figures. Okay. What happens if we take the upper bound and the upper bound? Now, of course, yeah, so 14.5 divided by 12.5. What happens when we do that? You see, we actually get a smaller answer. You take a bigger number, you get a smaller answer. Okay. None of these is going to be the right one, though. We need to mix it up. And that's going to give us something else. So let's now do the upper bound divided by the lower bound. Okay, so the upper bound is 14.5 divided by the lower bound 11.5. 1.261 to 4 significant figures. That's the biggest answer yet. Let's swap that around. The lower bound divided by the upper bound. So we take the smallest one there, 13.5, divided by the biggest one there. Okay. So 13.5 divided by 12.5. 1.08. So which one is the smallest answer? This one, definitely. Okay, so remember, when we work with bounds and it becomes to subtracting or dividing, then you need to mix things up. I mean, when it's add and multiply, it's easy. You want the biggest answer, you just take the biggest numbers. You want the smallest answer, you take the smallest numbers. You multiply, add them together. But division and subtraction, it's a mix. Okay, and to get the smallest possible answer, you take the smallest possible number and you divide it by the biggest possible one. So you don't have to work all of these out like I did. Okay, if you can remember that, then you'll save yourself some time. So the answer being here, 11.08. Is that rounded correctly? No, that's exact. Yeah, so there we go. Yep, 11.08. Question 22. The diagram shows a triangular prism ABCDQQ and a length 7 centimeters. Beautiful. The cross section of triangle PAB is 4 and 5, and there's a 90-degree angle. Calculate the angle between the line PC and okay, let's draw that line. Okay. Well, let's try. So the line PC will look like this. See? And we want the angle between that and the base. How do you get the... Yeah, it's a line, and now we got a 2D base. Okay, it's just the most flat part. So the angle they're asking for is here, this one. It's not as hard as it looks. Oh my word. Is that with a ruler? Did you use a ruler for that, mate? Yeah, this freaking ruler I'm using is not working. Let's try again. Unbelievable. Unbelievable. I'm just going to draw a straight line on this page. Well, something like that. Okay, so what do we have in that triangle? Well, in that triangle, we've got another 90-degree angle there. You see that? Okay, so this is triangle PAC. Let's draw it here. PA, there's a 90-degree angle, C. And in that triangle, we got 4 centimeters. And we want to know that angle there. So yeah, we don't have enough information there, do we? Okay, what do we have? We got another triangle, flat, bang, flat on the base. Okay, this one here. It's almost better, yeah? You see that? And there's another 90-degree angle there. We call that triangle ACB. Ugly B. Okay, in that triangle, we got the 7 and the 5. And brilliant. The right angle triangle, we got 2 sides. We want to know the hypotenuse. We're going to use Pythagoras. Okay, that means AC squared equals 7 squared plus 5 squared. Let's throw that square to the other side. It becomes square root. And we can get the answer straight away. Okay, nice. We can write it 8.6023, which is wise. Okay, don't round your answer yet. Or even better, keep it in third form. Okay, especially if you're going to be doing your exams from 2025 onwards. Thirds will be important. Okay, that's even better, because that's more accurate. Square root 74, yeah? So we now know that that AC is square root 74, which if I transfer AC, see, AC is over there, square root 74. So in this triangle now, PAC, we got 2 sides, we want an angle. Moment we got a right angle triangle, and we want to know an angle, we use SOHCAHTOA. Yes, SOHCAHTOA. So just label these things. We want to know PAC. This will be the hypotenuse, of course, opposite the 90-degree angle. Okay, which is over there. Okay, remember we want to know that angle there. This will be the adjacent. Okay, which is this side here. And then the 4, of course, will be the opposite. So we're working with the opposite and the adjacent. Yeah, remember, SOHCAHTOA, opposite, adjacent. There we go. So we're going to do tan. What we call the angle. Call that the angle PCA, APC, ACP. equals the opposite, which is 4, over the adjacent, which we got a very accurate square root 74, or 8.66023. Okay, so we want to know the angle. Gonna have to shift the ton over there and do the inverse, which is -1. Okay, so ACP, we just need to slot that into our calculator. Shift, ton, 4 at the top, square root 74, or 8.6023 if you like that more. Side arrow. A very accurate answer we got here, 24.937. Now we can round it. It's an angle, so we're going for 1 decimal place, 24.9. Okay, degrees. 24.9 or something less rounded. Okay, just be careful. Accuracy was often lost due to use of an insufficient number of significant figures. So just pay attention to that, yeah? Means just don't round your answer until the end. Or use the square root 74, like I said. Okay. Question 23, simplified. Beautiful. Look at this, it counts 4 marks. I mean, it must be trouble on the way. Okay, stay calm and start with what is easy. Okay, we're going to have to factorize, and the denominator x squared minus 9 is a complete square. That's easy to recognize. Remember, you got a square number there, a square number there, and a negative in the middle. Means you just can go x minus 3, x plus 3. Sweet, huh? Okay, remember, because when you expand those brackets, the middle term is going to eliminate. Yeah, easy to practice that, yeah. Okay, so that's easy. Now the secret is almost always we'll have a bracket at the top and a bracket at the bottom that can cancel out. That's what they're always going for. So I promise you, above the line, there'll be either x minus 3 or x plus 3. So we already got one bracket at the top. Okay. This is a little bit of a harder quadratic equation to factorize. Okay. But we know we're going to have a 5x and an x. Okay, because 5x times x is 5x squared. So we got that covered. All right. Then we got 12. Now to get to 12, we can do 2 times 6, 3 times 4, 1 times 12. But I bet you it's going to be 3 times 4 because we got 3's at the bottom. So that must be a 3 and that's a 4 because 4 times 3 is 12. Okay. Next thing we need to look at is what possible signs can we have here. Okay, so I'm going to make that 3 look pretty. Okay, think carefully. We got a negative there. Okay, so if the 4 and the 3 is positive, it will be impossible to get a negative there. If one of them is negative, then we'll have a minus 12 there. So the only option I see here is that we have 2 negatives. Because minus 4 times minus 3 gives you positive 12. Yeah? It looks like we've done it. Let's just double check. Let's double check. Is that correct? So if I got 5x minus 4, x minus 3, 5x times x is 5x squared, sweet. 5x times minus 3 is minus 15x. Minus 4 times x is minus 4x. Minus 4 times minus 3 is plus 12, sweet. And then minus 15 minus 4 is minus 19, sweet. Alright, you see how I did this? I started with the easiest bit. Put in what I could, use some reasoning, and things became clear after that. Now, x minus 3 divided by x minus 3 cancels out. Final answer 5x minus 4 over x plus 3. There we go. Okay, you get 2 marks for that. Okay, so just to make things clear, it's not as difficult as it looks. You get 1 mark for doing this part. It's just a little bit of practice, you got it. You get 1 mark for having 5x and x. And then you get another mark for it being correct. So you just got a 5x there and an x there, you get 1 mark already. Okay, and then you cancel that out and you have the correct answer on the line and you get all your marks. A little bit of practice, you're a genius. Question 24. Right, yeah, bad news. This proved to be the most challenging question on the paper with few correct answers. Okay, but we can do this, man. I think this was easier than that bloody sequence question. Anyway, right, so let's just see, right? Probability of Jimmy hitting a target is 1/3. Don't know what he's trying to hit, right? Let's say he's doing axe throwing. Yeah, okay. So he throws the axe, and the chance that he gets the target is 1 out of 3. The probability that he hits the target for the first time on his nth attempt is that. Okay, so nth attempt means he's trying more than once. Okay, so if he hits it the first time, we got a probability of 1/3. Okay, that's the first attempt. This is the first attempt. If he doesn't hit it, it means we got a no hit. So if he doesn't hit the target, the probability of that is 2/3. Then he throws his second attempt, and then he hits the target, that's 1/3. Okay, so the probability of that happening means he has to miss the first one, and he has to hit the second one. Remember with probability, the AND rule. Oh, not the ADD rule. The AND rule, that's multiplying. Instead of the OR, where we add, right? He has to fit the AND. So the probability of him hitting it on the second time would be 2/3 times 1/3 would be 2/9. Okay, we're done. We're a bit far away there from 64 over 297. Let's say, let's make some space here. Okay, so you get the picture here. We're going to have to multiply. If he hits it on his third throw, it means he missed the first and the second one, and then he got it in the third one. Okay, let's bring our calculator in here from now on. So we're going to make things go faster. Okay, so if the n, remember these from the n throw. The first throw, the second throw, the third throw. We know how many throws. Okay, so first throw, he misses. That's 2/3. Second throw, he misses. That's 2/3 again. Third throw, bam, he hits it. Chance of that happening was 1/3. That's a probability of 4 out of 27. We're going for 64 out of 287. So that means he's going to have to miss the third one and hit the fourth one. So going back here, we need to change that to a miss, which is 2 out of 3. And then put a 1 over 3. Not there quite right, yeah? You see that? But we're getting closer, so let's keep doing that. So that is 4 throws. Let's do 5. So 4 misses, and a 5th is a hit. We're getting closer. Let's do 6 throws. So 5 misses, and the 6th throw is a hit. Things are getting hot. 6 misses, and the 7th throw is a hit. Bam, look at that, look at that, look at that. So it means you throw 1, 2, 3, 4. Okay, let's change that. Then he threw it a 5th time, misses. He threw it a 6th time, misses. And on the 7th time, you got a hit. And you put that into your calculator, you get what we were looking for. That's it. That's it. 6 misses, 1 hit gives you that all in a row. So the answer here, 7. You see that? That K, where K is a 6. Yeah, B1 for 6. So 6 misses, and the 7th one is a hit. So the answer is 7. So 2 to the 2/3 to the power of 6. You get it. You get it. That's it. Okay. Yeah, that was the hardest on the paper apparently. Next one, the inverse. One method of doing this, set that equal to y. Now let's rearrange to make x the subject. First we subtract 1 from both sides. Then we do the opposite of cube, which is cube root. And that's it. Just change that y for an x. Final answer, cube root x minus 1. Yeah, that is it. And that's it. Ends up easy. And you've done it. Whole extended paper 2. There were some difficult ones here, but you are smart and you'll figure out and you'll get it right. Well done.